Okay, this says, without a calculator, how many times do the graphs of f of theta equals cosine of 2 theta and g of theta equals 3 sine of theta intersect on the interval 18 pi to 24 pi? Okay, let's get a good enough grid going. Okay, so the amplitude of this is 3, so let's make sure that can go up to 3, and this goes down to -3. The amplitude of this is 1, of cosine rather, is 1, so we'll make that -1 and make this 1. Now, this is kind of an interval that's far away from the origin, right? But these functions repeat, right? They're periodic functions, so we might be able to sort of figure out how these graphs look on 18 pi to 24 pi. And actually, we may not even have to sketch it. We may not have to even sketch the entire interval, okay? Because what's the period of g of theta? Let's write that. G of theta equals 3 sine of theta has a period of 2 pi. That must mean that it's going to do a full repetition on the interval 18 pi to 20 pi. Does one repetition, or one cycle. Okay. That must mean from 20 to 22, it's going to do another cycle, and from 22 to 24 pi, it's going to do another cycle. Okay, so we're going to do 3 cycles on this interval here. Let's see what the cosine graph does. So that's cosine of 2 theta. That has a period of pi. Okay, and so that means on the interval 18 pi to 20 pi, it does 2 cycles. Right, it's going to do one cycle from 18 pi to 19 pi, and then another one. So what we know at that point is that these behaviors are going to repeat from, so I'm just going to note, it's the same, right, same behavior from 20 pi to 22 pi, and also from 22 pi to 24 pi. So as a strategy, let's just analyze these graphs, sketch these graphs, and see how many times they intersect on that interval, and then we'll just times that by 3. That's the strategy. So again, this doesn't have to be perfectly to scale. Let's just say 18 pi is here, and let's just give ourselves a nice nice width here. That's 20 pi. That would be 19 pi. Okay, half of that would be 18.5 pi. That's also known as 37 pi over 2, and this would be 39 pi over 2. Okay, so let's do sine first. So if you evaluate 3 sine of 18 pi, okay, that is 0. Okay, so it's going to be 0. And if you plug in the next point, if you just want to make sure, 37 pi over 2, okay, notice that's the same, that's coterminal with pi over 2, because it's like 36 pi over 2. That's 18 pi's, and then a half of 1. But 18 pi resets you. So this will give the exact value as 3 sine of pi over 2, which is 3 times 1, which is 3. So I say that because it tells us my graph goes up to here. And then from here, we don't really need, we can just use kind of our pattern recognition of the sine graph. So it's going to do this. Okay, and as we suspected, it's doing 1 full cycle. Now this cosine graph is going to do 2 cycles on that interval. Okay, so why don't we plug in, again, 18 pi. So that would be cosine of 2 times 18 pi, which is cosine of 36 pi, which is 1. Okay, so at 18 pi, I get I get that. Now look, it's got to do 2 cycles by the time it goes from 18 pi to 20 pi. So it's going to do 1 full cycle from 18 pi to 19 pi. So I know that it's going to end up back here at a max at that moment. By symmetry, it must go down to -1 here. So that's 1 cycle. Okay. And then I'm going to do 1 more cycle. Okay. So again, it's going to have to do 1 more cycle by the time we get here. And just from this graph, we can tell there's 1 intersection here and 1 intersection here. And then there are no intersections from 19 pi to 20 pi. So that means there are 2 intersections on this interval. So that must mean from 18 pi to 24 pi, there would be 2 plus 2 plus 2 would be 6 intersections. Okay, because this exact picture is going to just repeat. It's just going to repeat 2 more times. So the answer should be 6.